Hey, David here. So, as well as being a complete tennis nerd, I'm also a fish nerd. So, I've worked with fish for the last 20 years. I've worked at Sakai Fish Farm, the world's best koi carp farm in Japan. I've worked at a tilapia and African catfish farm in Kenya. I've worked with arowana in Indonesia and worked in the import and export of tropical fish in a wholesaler, and now I'm working in an institute where we deal with do research on freshwater and tropical fish species. So, in the 20 years that I've been working with fish, I've seen it all, good and bad, and just want to share some of that experience with you. So, I am planning on designing and building a system for rearing fish eggs, and I just want to show you my plans and discuss why some things are like they are. First of all, I want to say sorry for the bad drawing. So I'm really bad at drawing. It used to really frustrate me because I'm a perfectionist, or used to be, not so much these days. And yeah, I had some really good things in my head but couldn't get them down on paper. But I've learned over the years to get them on paper, and yeah, saves a lot of mistakes later. So ignore the quality of the drawings. So you'll notice in the drawings maybe that not everything is included. So it's all included, but in separate drawings. I found that if you try and include everything in one drawing, it gets too busy. So here we have the rearing jar for the fish eggs. In another system, I'll explain how this works. So in another sketch, I'll explain how this works. The water then overflows into the aquarium. And this is just a stand that will hold the rearing jar and the rearing aquarium. The stand will be suspended over a big holding tank. So there's a PVC plate at the bottom, and there's a PVC plate there for the aquarium to sit on. Here I'm going to have a pipe clip, so this will hold the pipework that brings the water into the rearing jars. And this stand will be made out of, I'm not sure what it's called, but like some metal frame with plastic like fittings, and then you can get the metal cut to any size you want, and then you just bang it all together when it arrives with a hammer. So it's a really quick way of building. Everything's cut the right size already, and that companies that do that can be found on the internet. So that's the first drawing. So let's move on to the second drawing. So here I've just detailed the dimensions of the aquarium. So here will be a hole, and then inside the hole will be a mesh, and that will let the water come out, but it will obviously keep the fish in the holding aquarium. The particular one I'm using is called by a company called Savic. Knobby plastic aquarium. It's 10 litre. I use them a lot at work, but yeah, there's many other companies that sell them. And here I've just put a few dimensions. So the rearing jar with a little bit of extra space is 15 centimeters. The top from the floor to the lip of the overflow for the rearing jar is 41 centimeters. That will let me know how high to build the stand. And the metal stand will be 2 centimeters wide, the thickness of the material, and the PVC platter will be 1 centimeter wide. So that's just information that's useful when it comes to building the stand. Right, so here we have the rearing jar. So I'll just explain how it works for those of you who are not aware. So here is the pipework that's bringing the water down into the rearing jar. The water would then come down this tube, and then it hits the bottom of the rearing jar and then sprays up in this direction. The eggs are in here, and then this makes the eggs tumble around. So we basically want to have a tap on here, and that lets you regulate the flow. And that's really important because obviously eggs are different sizes, different weights, and for example at work I'm breeding tilapia, and they're very big compared to some fry, and so those eggs need more water to move them around. But if I'm breeding zebrafish and zebrafish eggs are really small, then if I have the same amount of flow, then the eggs will end up flying over here and going out the side. So we don't want that. So the flow needs to be adjustable. Good. And they need to be aerated because the eggs need to be they need to be moving with water going around them, circulating, because they need oxygen, and that keeps them alive. So I've drawn two different types. I've drawn a ball valve just with I can't remember what it's called in English, but in Germany we call it a Schlautuller. So just a fitting that lets you connect to hose. And this is my preferred option. So I've got again, I'm not sure what it's called in English, a Verschraubung, like something you can undo and remove the piece. And then into there, I'm in there on that side of the Verschraubung, I want an inside thread, and on this tap here there'll be an outside thread, and then you just wind the thread in here. And the reason I've put a Verschraubung in there is because if you need to clean anything, let's say this hose, if you try and pull this hose off, it can be really difficult depending on how long it's been on there for and how tight it is. And we need to be obviously careful around these jars. We don't want to knock one over. If you just undo this Verschraubung here, then you can take that away, clean it, and then bring it back and then screw it back on without risking damaging anything. So I still need to decide which size millimeter pipe to use here for this PVC pipe. So I've written that down to remind me. We also need a non-return valve on somewhere, either on here on the tube, or we need one on the PVC pipework. And the reason why we need a non-return valve is if you turn off the pump, then the water will start back siphoning up here and go out the system, and then you'll end up with an empty jar. And if you're not careful, depends how long this hose is, but a lot of the eggs will disappear up this tube as well. So that's really important, and must have a non-return valve on here, and I've put that down as a reminder. And it's good whenever you're building a system to turn the pump off and see what happens. You want to replicate what would happen in a power cut, quite often something you weren't expecting happens, and you need to solve that problem by putting a non-return valve in. Some other solution. Right, what else? I think that's it. So I need to decide which of these valves I'm going to use, but at the moment I prefer this one. And then what PVC pipework have we got? So this would just be like a flexi hose, silicone hose. We've got 3 T-pieces here, and we've got 2 end caps. For the end caps, I would make them with a thread, and the reason for that is you can then undo the end cap and clean the pipe. If it's end cap that you've glued on, there's no way of getting in here to remove any of the dirt, which will build up. Again, it's not 100% necessary, but it is a rearing system and we would like it to be as clean as possible, so our eggs don't become fungus. So it's a nice function to have, and it doesn't really cost any extra money. So yeah, it's something I will add. Yeah, good. So that's that drawing. So now the pipe work. So again, I can't draw very well, so this is the plan. So I'm going to have this stand on top of a holding tank. The pump is going to be in the holding tank. This is going to be a flexible hose. Then we're going to have Schlauteler, sorry, again, I can't remember what it's called, but yeah, something, connection to put the hose onto here. And then this is a place where we could have the non-return valve that I was talking about, so that water can't back siphon down here and we don't lose the eggs from the Zuga jar. So I think that's my favoured solution. So non-return valve there, so water can only go in that direction and not that direction. Then PVC piping, and then a T-piece here, and then these are the 3 T-pieces that are taking water into the rearing jars. They're obviously not facing that way, they're facing down, but because I can't draw 3D, I've done it like that. I think it's quite clear. Here's a better drawing that shows it better. Yeah, and then the pump is in the water. Good. And then plan on having, so these are the jars here. This is the water coming from the jars, and then there's going to be 3 plastic aquariums next to each other. So they're 10 litres, and there's a mesh in each of those. I'm not sure if I will do this, but another option would be to have some guttering. And the water comes out of here, collects in the guttering, flows down here, and then goes back down into the tank below. It's not 100% necessary. It's nice, but also the water could just fall down there into the holding tank. I'll see if I decide to do that. I drew the gutter in here at the bottom, where the bottom of the tanks, but there's also, you could raise it up so that it runs along here and catches all the water as soon as it comes out of the mesh. That would cause less splash. Need to decide how I'm going to hold the guttering in place. Probably connect it to a PVC plate. That's it for that drawing. And then this is the holding tank. So because of my drawing skills, I haven't been able to add them both together. But the stands that we've been talking about, and I've shown you the diagrams of, would be suspended over this holding tank. Inside the holding tank, there's going to be 2 circular tanks. The water level can't be too high, otherwise these circular tanks start floating. So I've cut this standpipe here to the height where the maximum height of the water before these start floating, and then that makes sure that no one can overfill it. Obviously we don't want the tanks floating and maybe becoming buoyant and then tipping over and letting all the fish out. So that's the reason for that. So the rearing jars will be on top of here, and the water from the rearing tanks and the rearing jar will be from this tank here. So this water is separate from this water. And the reason for that is if we've got fish in here and we're feeding them, we don't want all that dirtier water in with the eggs. So this is just completely clean water at the right temperature that has not been near any other fish. So we've got a really nice, clean, sterile environment. The water in this tank and in the main tank are the same water. So there's an overflow pipe in the middle here. So the water goes down the pipe and flows out into here. Why have I got a standpipe in here? Well, it's really important to have, so if you want to be successful at rearing fry, you need good water quality. You can either get that by having a really good filter or a really large volume of water. Both is nice, but I'm setting this system up on a tank that's got no filter, so I'm making do with what I've got. So if I started from scratch, then yeah, I'd possibly build in a filter, but this system hasn't got a filter, and I like to be flexible and be able to work with any system. And so yeah, we've got a large volume of water here. That's really important, because if you get bad water quality, then your fry will die. And so yeah, large volume of water. We want fish in a confined space when they're fry, when they're babies. So those aquariums are 10 litres. And that's really important, because we don't want the fish having to look for their food. We basically just want them swimming in their food. So when they're babies, they're really vulnerable to dying, usually due to underfeeding. And if we've got them in a small volume of, in a small tank, and we put food in it, they basically don't need to look for their food. They just swim into it. So a large volume of water, but the fish in a small volume of water. But this small volume of water is connected to the large volume of water. Then we can feed lots. When I say feed lots, at least 5 feedings a day. Underfeeding will kill baby fry at this age. So some people, cleanliness is more important to them than feeding. Obviously, if you feed a lot, you've got a lot of waste being produced. But at this age, it's more important to overfeed than underfeed. So yeah, if you want to be successful at rearing fish eggs and babies, then follow this. And I think that's it. So yeah, sorry, I can't remember if I said, but yeah, so the stand will be suspended on here. The water will be getting pumped from out of this round tank, and then it will fall back into this tank, and it will just be recirculating. So that's the plans, and I will now go away and order the materials, and then I will make another video with the built system for you to have a look at. Thanks very much for listening. Take care. Any likes, please subscribe, comments. I'd love to know if you found this useful. Thank you very much.